Here though.
Okay, so let's look at an example. The first one I want to show you is one where we actually have continuity, and it's going to be one that I think in a lot of ways we sort of know already something about. So to discuss the continuity, or determine the continuity of f of x equals x squared minus 2x plus 5. You, as experienced mathematicians, probably know a little bit of something about that function already. What's one thing that you know about that function already? It's a what?
Parabola.
It's a parabola. It's a quadratic. So you already have, hopefully, a mental idea of its basic shape. Is that right? Now, this particular parabola, does it open up or does it open down? Okay, so we know something about it. Because of those properties, we're going to work through the proof of continuity, because that's what it is. And I'm just going to kind of number each part. We're going to talk about step one, and we want to say, now, we need to discuss in step one, does this function have values that exist for every x in the domain? By the way, for this function, what would be the domain? What was that? Yeah, the domain is x is an element of the interval from negative infinity to positive infinity. It's all real numbers. So now, when we think about any real number that I could pull out of that domain, could I plug that into this function, and would I then get a real number out of the function? What do you think? Can we imagine any exception to that? There's not. The things we know about parabolas, we talked about them, we've looked at their properties for a few years now. We should know that any number you put into that parabola is going to come out. Now, we get farther in mathematics, we're going to actually have to really detail prove that. And not just sort of, in this case, mathematical theorists say you kind of hand waving across it and you're sort of describing it. You say, we're going to say this works. And we're not going to give you all the minute details because we're not ready for that yet. But we still need to say a little bit of something to say why every one of those answers works. And the nice thing about this kind of function, it's a polynomial. You remember polynomials from last year? Okay. Polynomial functions. They are under a category of functions that we call well-defined functions. And with these well-defined functions, we are able to say that any x gives me a y number. And that's really all we want to have happen here. Okay. So since f of x is a polynomial, it is well-defined, and f of c exists for all c out of the domain from negative infinity to positive infinity. And really, we're relying on our knowledge about polynomials and how they have values that show up. And their domains are all real numbers anyway. So it's some of that prior knowledge. Again, if you get farther in math, you're going to have to actually prove that that's actually true without being able to just say it. I'm going to let you say it in here. Does this make a little bit of sense? Yes?
So what do you say if it's not a polynomial?
Then we have to maybe consider certain things. When it doesn't fit in the polynomial, maybe it's a square root function. So you have to talk about what its domain is, and then within that domain, do we always get answers? Maybe it's a rational function. You have to talk about what that does and how that impacts things. Is your domain itself, in this case, broken up, or is it just all continuous as one set of values? So your interval, your domain will tell you a lot. And I'll look at a couple of different examples here in a minute to do that. Other questions?
So basically, you always need to find the domain before you start trying to...
I would definitely say find the domain first. Okay. So the second thing we want to consider here is the limit itself. Now, we have looked at various ways to find the limit. We looked at graphing ways, we looked at table ways, we looked at algebra techniques. If I was asking you to find the limit of some value in a polynomial like this, what technique will you probably utilize? If I specifically say, can you find the limit of f of x as x approaches 7? Probably what would you do? Okay. So, is there any number which you would not do something like that with? No. So, again, this is going to be, wow. It must be Monday, guys. This is one of those functions, it is a Monday, that f of x, no, sorry, I done that one, limit as x approaches c of f of x exists because f of x is a polynomial and the limit would be found by algebra substitution. Basically, you replace it with the x with the number and use find. Is kind of what we're saying here. But that means the limit exists. Should we good with that? Ready to read that again?
Wait, why'd you put the therefore?
That's a because.
I thought that was therefore.
No, therefore is this one. Because is that one. I know, it's good stuff.
Okay.
That's because. Okay. The third thing we're trying to do is we need to kind of show that the value of the function and the value of limit are the same thing. So for this one, we can basically say the limit as x approaches c of f of x, well, I sort of already set it up here. To find it, I'm just going to find f of c. Those are identical. And this is true for all our c's in our interval from negative infinity to positive infinity. And again, it goes back to because this is a polynomial.
Are we only going to be working with polynomials?
Oh no, of course not.
Right, because it could be easy. That would just be nice.
Actually, I think in some ways these are the harder ones because it's hard to come up with why does this really actually work and think about all the possibilities where it won't. Later, when there's some that maybe don't work, we'll be able to draw our eyes to things much more readily and either say yes or no. All right. So am I done with this? Have I shown the 3 steps?
Yes.
So am I done with this?
Probably not.
You would be correct. No, we're not.
Therefore.
So now, to be done with this, we actually just say this is continuous. If it's not continuous, we say this is not continuous. But as a proof, we've got to draw our conclusion to get everything going. All right. Questions about that?